assume or pretend that the concept vector is not introduced. No compass, no directions, nothing. Okay, so and you have here three scenarios. Look, in this case, the school case, your friend told you that the school is located 10 kilometers away from your house. So how do you get there? And the driver here said he's driving 8 kilometers an hour to reach you. So in which direction is he driving? And the pilot here wants to drop extra bag. Let it be the ocean. The ocean is somewhere here, okay? But he don't know where, at what angle he has to drop. Pause the video and think those three scenarios. How do you determine without a vector this situation? The power vector comes here. Without vector, it is too difficult to determine those situations. So we need quantities that express the direction. In this case, it says 50 kilometer, okay, 50 kilometer away from the house. All right, so but that 50 kilometer could be in this direction. It could be in this direction. It could be in all directions. We reach there. The same is true here. The car is driving, let it be 8 kilometer an hour, but I don't know where it is and which direction he's driving. Is he driving to the north, east, south, where? The same is true for the pilot case. So we need quantity which shows us the directions. Powerful vector. So vector, all right, vector is a quantity. Vector is a quantity, okay? A quantity that has magnitude plus direction. Okay, those quantities which has only magnitude are called scalar. Okay, scalar quantities. Okay, so we have a lot of scenarios in real life, in mechanics, physics, geography. So vector is everywhere, I can say. Quantities which has only magnitude are called scalar quantities. For example, look at this one, 50 kilogram. Okay, the mass of an object, 50 kilogram. We can't say 50 kilogram east. That's meaningless. South, north. The same is true for time. All right, 6 o'clock west, north. Doesn't give sense. This is scalar quantity. Okay, temperature, and so on. So we have quantities. At the same time, we have quantities, vector quantities, which needs direction. Example, force. All right, force is a vector quantity, the product of acceleration and mass. Mass is a scalar, but acceleration is a vector. So the direction of this vector, acceleration is in the direction of the force. Momentum needs directions. Displacement. Okay, displacement is a vector quantity. Displacement need direction. That is speed, I mean distance plus direction. Okay, velocity is speed plus direction. This all needs direction. Next, how do we represent then? How do you represent a vector? Representing vector. How do we represent vector? Okay, geometrically and algebraically. Okay, algebraically and geometrically. So algebraically, it is represented by letters. Okay, we can represent letters using bold or A, okay, V, whatever, just H, B. So we can use letters and on the top arrows. Okay, that arrow shows the directions. Geometrically, we can even simply use an arrow. Okay, let it be AB. Okay, so geometrically we can represent this way. Okay, but if we use the letter, for example, if we say in words vector example AB, we don't have to write AB and again arrow there. But if we use just the symbol like AB and arrow on the top, we don't have to write the word vector, just to mean vector AB. Okay, you don't have to write this way. So geometrically and algebraically you can do it this way. Sometimes you just simply write here A, vector B, vector C, whatever the letters. Okay, all of you write it in this way, let it be vector AB. Okay, the line segment, this line segment is a magnitude. Okay, magnitude, but the arrow shows the direction. The arrow shows the directions. Always A, in this case A is the one which is close. The tail is initial and this one is terminal. Okay, so it has initial and terminal points. Next, let's see the forms of vector. Okay, we have two forms of vectors. Alright, the first one is magnitude direction form. Direction form. The second one is component form. So the magnitude direction form, as you can see from the name, it shows us the magnitude and directions. For example, if you have this vector, okay, and the angle will be given, that's the direction, and the magnitude will be given. Let this one is R. All right. So it's represented by you can write R theta. Okay, magnitude and directions. For example, we can say 5 kilometer in the direction of 60 degree east of north or north of east or something. Okay, 60 degree. This is just an example. Sometimes it is called polar form. Because they start with from the origin. Okay, polar form. The other one is component form. Okay, component form. It's actually it's represented by if this is x and y, it has a component. For example, if you have a vector, so it has this has two components. Okay, this has two components. Let with the x component is a and the y component is b. Okay, so we can represent this for example vector by its component. Usually you can write as AB. Okay, column form, column vertex, column form, not vertex. So or you can also write as for example AI plus BJ, where I and J are unit vector. Okay, unit vector. We'll see in detail this later. So these are the two forms of vector. How do you calculate the magnitude of the vector? Okay, we have this vector, okay, which is 3 units from the origin and 4 units up along the y-axis, positive y-axis, and so to find this magnitude, all right, this is of course expressed as 34. To find this, use Pythagoras theorem. This is 90 degree. Okay. So magnitude of a vector is represented by kind of two parallel line or absolute value. Okay, let this vector is A, vector A, So this is how it's represented. And in order to find, you have to use Pythagoras theorem, 3 squared plus 4 squared, which is equals to 9 plus 16, 25, and the square root of 25 is 5 units. This is the magnitude. To find the direction, okay, the direction from the positive x-axis, all right, so you have to use theta, usually help us to find the directions. So theta is equals to, you can use tan inverse of y over x, because this comes from the fact that if you have a right angle triangle, if this is theta, if this is y and x, so tan theta is opposite over adjacent, therefore you have y over x. So in order to find theta, you have to reverse, so tan inverse of y over x, which is in this case tan inverse of 4 over 3. Okay, this can be the direction.